I do tell it how it is, you're right. Okay, so let's remember this first part you're not taking notes on, you're watching. How do we simplify radicals? Don't we break it down and pull out groups of however big this is? So this would be 8 times 5, wouldn't it? And then 8 is 2 times 2 times 2. So then pulling out groups of 2, because it's a square root, so we'll pull out a 2. And then root 10 is left. Are we all good? Okay, moving on. Now look, there's x minus y to the 5th. That means there are 5 x minus y's in here. 1, 2, 3, 4, 5. I'm going to do dots because I don't want to write x minus y. So we'll pull out 1, 2. How many x minus y's? 2 x minus y's. So we'll have an x minus y squared. And then how many was left? 1. Square root of x minus y. You know, everyone listen. We all know it is breaking the most forbidden of all forbidden rules. If I said x minus 1 squared, we know it would be breaking the forbidden rule to square that and square that, correct? Well, now look, x minus y, this is x minus y to the 1/2 power, which is no different than x minus 1 to the 2nd power. So could we just square root that and square root that? No, that'd be breaking the forbidden rule. So look, because there's a subtraction sign, you can't just square root this and square root this. That is way forbidden. So our answer should have stayed as just the square root of x minus y. Is everybody good with that? Okay, moving on. With this one, we would break it down. 8 is 2 times 2 times 2. X to the 5th. If you were desperate, 1, 2, 3, 4, 5. And I'm not going to do the 6. So everybody will pull out groups of 2. Pull out a 2, pull out an x, pull out an x. Correct? 2x squared. And then you said y to the 3rd. Good. Because 6 divides by 2 3 times evenly. So then left under our square root is a 2 and an x. Okay, moving on. So everyone, I'm asking you an important question. I hope you're focusing. Can I just square root that, square root that? No, because of the addition sign. Do not do that. You can't do that. So instead what you do is say, I need it to be multiplication, like this. Multiplication, we can just square root each piece. But it's not multiplication, it's addition. Well, if we factor it in some way, we might be able to write it as multiplication, because factored is filling it apart into a multiplication problem. So let's factor out the greatest common factor. What is in each term? 4. So then we'll be left with x squared plus y squared, true? Now look, we have a multiplication sign right here, so now we can split it up. The square root of 4 is 2. And now we have the square root of x squared plus y squared. Would it be appropriate to just square root that and that? No, because of the addition sign, so we'd be done. Then we would keep going. Yeah. Okay, so everyone, when do we need absolute values? Just a reminder. We need absolute values in our answer if we have an even root and our answer has an odd exponent. So look at this example. The square root of 49x to the 6th, y to the 8th. I've simplified that. It comes out to be 7x cubed, y to the 4th. So you check. Even root? Yes. Odd exponent? Yes. So I would add absolute values. Odd exponent 7 is a number. It's not a... Numbers never get absolute values. And then y to the 4th is an even, so we would not need absolute values. So when do we need them? Even root, odd exponent. Okay, so now we can begin today's lesson. Simplify the radical. We've already done this year. So simplify the radical. So how do we multiply radicals? Well, if they have the same index, you guys, you can just put them under the same house. Square root, square root. So isn't that the square root of 15? Now, if we broke it down and pulled out groups of 2, that would have been the square root of 5 times 3. Nothing pulled out, right? Okay, so with this one, they're both cube roots. So I have the cube root of 2 times 13. I'm going to write it like this, because what if I need to break it down? Then I might as well leave it factored. Well, can either of those break down? No, so if nothing breaks down, you multiply what's left underneath, which is the cube root of 26. So we get a picture here. Looking at this one, square root, square root. So we can put them under the same square root. So we would have the square root of x minus 3 times x plus 3. Do you see how I'm putting in parentheses? Because I have 2 terms. Yes. Yeah, so now we would look and say, is there any groups of 2 that we can pull out? No, they're not the same. Look, x minus 3, x plus 3. So there's not 2 of them. So then we take our answers and multiply them back together. That's always what we do. If anything's left underneath, you multiply back together. So we have the square root of x squared. Minus 3x and plus 3x cancels out, so x squared minus 9. Don't get tempted to start doing square root, because that would be not okay. We can't do it. Yep. Okay. I think we get the picture here with this. Don't you agree? Okay, let's do some that do simplify. So everybody, it says simplify. You'd say they're both under a square root, so let's put them together. Do not actually multiply them together, because then you'd re-split them right back apart. 3 breaks down into 3, doesn't it? 15 breaks down into 3 and 5, and then I'm not going to double dip, meaning if you write something as something else, cross it out. So I'll pull out a 3, so left is root 5. Pretty easy stuff, right? So now looking at this one, we have a 3 on the outside. Then we have the cube root. Watch what I do. I reorder things that are alike by each other. So we have a 4 and a 2, so 4 times 2. Then we have an x, and then we have x to the 4th. So now break it down. Isn't 4 2 times 2? Yeah. Then we also have a 2 from that too. Then we have an x, and then we have 4 x's. 1, 2, 3, 4. Pulling out groups of 3 in this one, aren't we? Yeah. Pull out a 2, pull out an x. So then look, 2 pulls out, and 3 was already outside, so multiply it to it. 6x, and then cube roots of? X squared. Yep, x squared. Okay, I think we're good. Oh wait, I haven't been adding absolute values, we better check. So even root, numbers never need it. Even root, no, so we don't need absolute values. Let's do this one. So we have the 4th root of 27 times 6. Then we have an a squared and a cubed. Then we have a b to the 5th, b to the 6th. I'm going to do this an easier way. I'm going to think more advancedly. Instead of writing out a bunch of b's, I'm going to just put them together. So 27 breaks down into 3 times 3 times 3, doesn't it? Yeah. I'm doing that way quick in my head. And then 6 breaks down into 3 and 2. And then there's 2 a's and 3 a's, so wouldn't that be a to the 5th? Yeah. And then there's 6 and 5, wouldn't that be b to the 11? Yep. Okay, pulling out groups of 4, so we'll pull out a 3. How many groups of 4 are there here? So a, 4th root, 2 is left, and then now an a is left, right? Now 11 divided by 4 is 2 point something, right? So it comes out evenly twice. So you pull out b squared. Now look what you do. 2 times 4 is 8. How many remaining to get back to 11? 3. So that'd be b to the 3rd left. But yes, if you're desperate, write out 11 b's and circle groups of 4. Even root. Checking. Look, look, look. Even root, yes. Odd exponent right here, yes. So I need absolute values.
Wait, was that the even root exponent for the a root? Or the a to the 3rd?
Here's our answer, right?
Oh, if it's at the end.
Right, look at our answer, yeah. Okay, I think we get the picture with that. Do you agree? Okay, this is what you do need to take notes on right here. If you're multiplying 2 radicals together that do not have the same radical, you can still actually put them together. It just takes a little bit different approach. So look, square root and cube roots are not the same house. So you cannot just put them under the same house until they're the same. They're not the same. So we're going to have to do this a little differently. First, rewrite it with fractional exponents. Second, then get a common denominator. Third, rewrite it as a radical and multiply it out. It's actually really easy. So, 2 to the power of 1/2. Does everybody see how he's getting that? Roots go on bottom, power goes on top. Then we have a times sign. Then we have a, I keep writing 3, but it's 4. We have a 4 to the what power? 1/3. Yep, 1/3. Now look. Our roots, which means our bottoms, because roots are on bottom, need to be the same. So wouldn't we just get a common denominator? So we'd multiply by 3 over 3. This one would multiply by 2 over 2. So now we're looking at this. 2 raised to the 3/6 times 4 raised to the 2/6. Now look, they're both under a 6th root. So now we fix it so that we can multiply these together. So this is equal to the 6th root of 2 to the 3rd power, right? 2 to the 3rd power. And then 4 to the 2nd power. And then you just better make sure it doesn't simplify. So 2 to the 3rd power is 2 times 2 times 2. 4 to the 2nd power is 4 times 4, which is 2 times 2 times 2 times 2. So pulling out groups of 6. So that would be 2 6th roots of 2. All right. Pretty easy though. Just get a common denominator and then you're good. So like a lot of times they won't simplify. For example, this one. So just watching x to the 2/5 times x to the 1/2. You'd get a common denominator, which is 10, right? Times by 2 over 2, times by 5 over 5. So then we have x to the 4/10 times x to the 5/10. So then that would be the 10th root of x to the 4 and 5 is 9. And then we can't pull anything out because there's only 9 of them. So it doesn't simplify. Okay, let's go on to dividing radicals. So when dividing radicals, if you have like radicals, you'll just simplify what's under the radical first. Guys, we've got to tackle it in this order so that our life's easier. There are many ways to simplify these radicals, but if you do it this way, you shouldn't need to rationalize any denominators, which is nice. So first, always simplify what is under the radical first. Then second, split apart the top and bottom and simplify it further if needed. Meaning, simplify everything underneath, and then if you still have to take the square root of the top and bottom, split it back apart, and then just simplify them individually. Simplify the top, simplify the bottom. But it really is important to first simplify what's underneath if it does. So everybody look at this one. We have the square root of 64 over 4. The inside of the radical would be what we do first. Simplify it first. So that's the square root of 16. Well, that's nice, because now what do we have? The square root of 16 is 4.
Well, are we gonna just like if it was like 64 over like 6 or something, like if it didn't divide out.
That one, yeah. Yeah, we will go over it. Okay, so let's look at this one. Square root of 18 over 25. Does 18 and 25 simplify? No. So what would we do? Split up the top from the bottom. So you'd say, okay, so on top I have the square root of 18. On the bottom I have the square root of 25. And then all you have to do is simplify them individually. So say, okay, square root of 18 needs to be simplified. So that's 9 times 2, which breaks down into 3 times 3. So 3 root 2 is on top. Isn't that 18? Square root of 18 simplified. Now what's the square root of 25? 5. 3 and 5 don't simplify anymore, so we're done. Now I do want to point out, in this problem, the radical is on top, not on bottom. If it's on bottom, we would have to rationalize the denominator. But like I said, in this unit, not in this unit, in this lesson, in this unit we will have to rationalize denominators, but in this lesson you won't if you tackle them right. Okay, next one.
So if you do it right, you go.
In this lesson, yes. Okay, so we have the cube root of 6z cubed over 125. Underneath the radical doesn't simplify, so we'd split it apart. We have the cube root of 6z cubed divided by the cube root of 125. So then simplify the top. Now 6 is, so the cube root of 6z cubed, 6 breaks down into 3 times 2. There's not any groups of 3. But can they pull out a z? So then left would be the cube root of 6. So we pulled out a z, left was the cube root of 6, and then on bottom the cube root of 125 is 5.
I'm done.
Did the radical end up on top or bottom? Top is fine, right? Bottom we would have needed to rationalize. Okay, I think we get the picture with these ones. Okay, let's do this one. Once again, look at the problem. If you just start simplifying the top and pulling out groups of 2 in the bottom, pulling out groups of 2, you're going to do it, it's not going to work out. Because look, doesn't nothing pull out here?
Yeah.
Then we'd have to rationalize the denominator. So you're making your life hard by not following the first step. The first step is to simplify what's under the radical first, meaning put this back together. If it's split apart, it can be put back together. So we have a 24a cubed. Then on bottom we have 6a. Simplify what's under the radical first. So that would become what?
4 over 1.
4 over 1, and then
A squared.
on top, right? So now over 1 doesn't matter, right? So you can ignore that. Well, now look how much easier that is. What's the answer?
2A.
2a. That was a lot easier than rationalizing the denominator to simplify, which would have ended up with the answer 2a, but through a much more advanced process. Okay, another one. First, put the cube roots together and simplify. So I'm going to ignore -2 for a second, but I got to remember in the end. So I have the cube root of 54. I have a on top, and then I have a 2a to the 4th, which is the cube root of 54 and 2 becomes 27 on top. A and a to the 4th becomes a to the 3rd. Now we would split it back apart. On top we have the cube root of 27. On bottom we have the cube root of a cubed. So the top had a 3, right? Cube root of 27 is 3. The bottom is a, and then we just can't forget in the top there was also times -2. So our final answer is -6 over a.
Oh, I like this lesson.
Yeah, it's pretty straightforward. Hey, I'm almost done. This is my last example, then I'm going to let you work on 7-3 for like a half hour. Here we go. So putting it together, watching this one, last one. The cube root of negative 375 x squared y divided by 3x to the negative 1 y to the 7th. So, cube root of, looking at this, x to the negative 1, shouldn't I just make it x to the positive 1 on top? So now we have negative 375 divides by 3 and becomes negative 125 on top. We have an x squared and an x to the 1, which is x cubed on top, right? Then on bottom, what do we have? Y to the 6th. Y and y to the 7th. You guys see why we're getting y to the 6th. Now split it apart. So the cube root of 125, the cube root of negative 125 is negative 5. We always pull out the negative if it's under an odd root, right? The cube root of 8 is 2. The cube root of negative 8 is negative 2. It's okay to have negatives under odd roots. It's just the answer is negative. So then the cube root of x cubed. X. And then on bottom, the cube root of y to the 6th. Y squared. Pretty easy stuff, do you feel like? Yeah? Okay, awesome. Go do 7.3, the same theme, evens or odds, and once again, yeah, you do have a little leniency to choose how much homework you do. But once again, don't get too confident.